Hello, and welcome to the Unit 4 test review for Part 2. Let's start by solving the equation of number 1. I'm going to begin by drawing a line down the middle of the equal sign. Now, my goal is to get x by itself. So the very first thing I'm going to do is add 7 to both sides. And I want to do that because I want to get that minus 7 away from the 9x. And the opposite of minus 7 is plus 7. They cancel on this side, so all we have left on the left-hand side is 9x. On the right, negative 7 plus 7 is 0. For my last step, I'm going to divide both sides by 9 because 9x is 9 times x, and we undo multiplication with division. On the right side, 0 divided by 9 is 0. Number 2. I always begin by drawing that line down the middle of the equal sign. Now the first thing I notice here is that I have two different types of x's on the left side. I got a negative 15x and a plus 5x, so I'm going to combine them. Negative 15x plus 5x is negative 10x. The plus 21 just comes along for the ride, equals is still in the middle, negative 19 is still on the right. Now I want to get x by itself, so the very first thing I'm going to do is undo the plus 21 by subtracting 21 from both sides. All I have remaining on the left-hand side is negative 10x, and on the right side, negative 19 minus 21 is negative 40. I'm going to finish this problem up by dividing both sides by negative 10, because I want to get x by itself. X equals positive 4. All right, let's take a look at number 3. Okay, number 3 is a fraction, but don't worry about it. We'll sort it. Oops. There we go. All right, line down the middle. Now I want to get x by itself, so the very first thing I'm going to do is undo the minus 7 by adding 7 to both sides. On the left, the 7's cancel, and all I have remaining is 3 over 4x. And on the right side, 14 plus 7 is 21. The way we get rid of fractions is we multiply both sides by the fraction flipped upside down. On the left side, the 4's cancel, the 3's cancel. That's why we do that. And all we have remaining is x. On the right side, 21 times 4 over 3, which I expect you to do in your calculator, gives you 28. All right, number 4. Now, number 4, one thing I noticed that's special here is that we have x's on both sides. My personal preference is to move the x's to the left, but it really doesn't matter how you start this problem. But, since I'm making the video, I'm going to start by subtracting 4x from both sides so I can get the x's by themselves. On the left, 8x minus 4x is 4x. Plus 6 comes down, and all I got left over is a negative 14. My next step is going to be to subtract the 6 from both sides. Because I had a plus 6, I'm undoing it by minus 6. So now I have 4x equals negative 20, and I finish this problem by dividing both sides by 4. X equals negative 5. Oh, that's an ugly top. There we go. Let's take a look at number 5. Now, number 5, I noticed the special part about it is that it has parentheses. What the parentheses are telling us to do is to distribute. We're going to distribute this negative 5 to the x and to the negative 4. First, I'm going to bring down that negative 3x because there's nothing I can do with it. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. Nothing changes on the right side. Now on the left side, I notice that I have two types of x's. I have a negative 3x and a minus 5x. Negative 3x minus 5x leaves us with negative 8x. The plus 20 comes down, and then we have the equals 28. My next step here is going to be to subtract 20 from both sides, again, because my goal is to get x by itself. So I've got negative 8x on the left. 28 minus 20 is 8. And I'm going to finish this problem by dividing both sides by negative 8. So we get that x equals negative 1. Our goal is always to get x by itself. All right, number 6. We have some more parentheses here. That means we're going to distribute that negative 4. Line down the middle. Negative 2x just kind of drops down. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. And it equals 30. Just like in the previous two problems, I have two types of x's here. I have a negative 2x and a minus 4x. Negative 2x minus 4x is negative 6x. The plus 12 drops down, and so does the equal 30. My next step here is going to be to subtract 12 from both sides. I'd like to get x by itself, so I'm moving everything away from it. So I've got that negative 6x equals 18. And I finish this problem up by dividing both sides by negative 6. And again, my goal is to get x by itself, and that's what we did. Okay. So those are some multi-step equations, which we'll definitely have on that test. If you have any questions about what's going on here, make sure to ask us. By us, I mean me, myself, and I, or your other teachers. Now, number 7 or 8, what I'm asking you here to do is just to determine whether each equation has one solution, no solution, or infinite solutions. I'm not asking you to solve it. But in order to find out what amount of solutions they have, we do need to do some distributing. I'm going to put the line down the middle here. Let's zoom into number 7. I'm going to distribute the negative 2. That means I'm going to multiply. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. There's nothing for me to do on the right side, so I'm just rewriting it. Hopefully at this point you notice something about the x's. They're the same. When x's are the same, we're either going to have no solution or infinite solutions. When x's are different, we can safely say we have one solution. All right. So what I'm going to do here is I'm going to cross off the negative 2x's. We don't even need them anymore. They're the same. They're gone. I am left with 4 equals negative 3. Now here's how we decide how many solutions we have. Does 4 equal negative 3? Absolutely not. No solution. Number 8, let's draw a line down the middle. On the right side, it looks like I don't really need to do, on the left side, nothing I need to do. On the right, however, I do need to distribute the negative 7. Negative 7 times x is negative 7x. Negative 7 times negative 5 is positive 35. Once again, I'm left with 2 of the same x's on two sides, so I can cross them off. All that's remaining is 35 equals 35. That's correct. So we have infinite solutions. That's my attempt to draw infinity without turning my screen. It should look like a sideways 8, but clearly I'm not good at drawing it. Alright, for number 9 and 10, what I'd like to do is just to write up the inequalities that we're going to, that represent this problem. We do not need to actually solve them, but we do need to write an inequality to represent them. Admission to the zoo costs $25. Each special exhibit costs $10. You have $135 to spend at the zoo for admissions and exhibits. Express the number of exhibits you can visit as an inequality. The first thing I want to write down is the amount of money that I have to spend, and that is $135. Can I spend more than $135? No, that's all the money I have. So whatever I write next should be less than $135. Can I spend all of my money? Absolutely. So I'm going to write an or equal to. Now, admission to the zoo costs $25, and we have no choice over it. It's going to happen. 25 happens. We don't have an adjusted price. That's just what we have to pay. We are also, so plus, looking to go to exhibits for $10. So each exhibit costs $10. That's where we get that first 10 from. Now, I don't know how many exhibits I want to go to until I solve this problem. So the way I represent not knowing something in math is with a letter. I'm choosing X for exhibit. Each special exhibit. So I can spend my $135 on admission of $25 and $10 for every special exhibit. Let's also do the same thing for number 10. Pauline got $250 for her birthday. She already spent $40. Her plan was to use that money to buy McChickens after school during the school year. Oh, sorry. Each McChicken costs $1.50. Write an inequality that represents the amount of McChickens she can buy. Alright, so Pauline started off with $250, so that's what we're going to write down. Can Pauline spend more than the money that she has? No. So everything must be less than $250. Can she spend all of her money if she feels like it? Absolutely. Or equal to. Now, she already spent $40. We can't get that back. It's spent, so we're just going to write down that 40. She would also, and her plan is to use that money for McChickens, so plus. Each McChicken costs $1.50. Let's highlight that. 150. I don't know how many McChickens she can buy, so in math, when I don't know something, I represent it with a letter. I prefer X, so I'm writing X. Okay. Now let's do some solving of inequalities. When we solve inequalities, we have to graph them on our number line too. The way we solve inequalities is exactly the same way we solve equations, with one special rule. If we multiply or divide by a negative number, we must flip the sign. Let's start with number 11. I'm going to put a line down the middle. My goal is to get x by itself. So I'm going to start with subtracting 5. They cancel on the left-hand side, and all I have remaining is 6x. On the right side, 35 minus 5 is 30. All I did was subtract, so my symbol doesn't change. I'm going to finish this problem by dividing both sides by 6. Now the 6 that I'm dividing by is positive, so my symbol stays the same. X is greater than 5. Positive 5 gets an open circle on it. Greater than means to the right, arrow to the right. Now I know it's greater than because the inequality symbol has its mouth open to x, so that means x is bigger. All right, number 12. I'm going to put a line down the middle. Now whatever answer I get for number 12, my dot on the number line is going to be colored in because I have a line underneath my symbol. My goal is to get x by itself. I'm going to begin by subtracting 7 from both sides. They cancel on the left. So I've got negative x. I only subtracted, so my symbol stays the same. 10 minus 7 is 3. So negative x is less than or equal to 3. Now negative x is actually negative 1x. So I need to divide both sides by negative 1 in order to get x by itself. Because I'm dividing by a negative number, my symbol flips. And 3 divided by negative 1 is negative 3. X is greater than or equal to negative 3. Negative 3 gets a closed dot on it. X is on the open mouth of my symbol, so my arrow points to the right. All right, 13. This is going to have an open circle on the number line because my symbol does not have a line underneath it. The first thing that I got to do here is I got to distribute. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. Symbol stays the same, negative 44. Since my goal is to get x by itself, I'm going to begin by adding 16 to both sides. I'm left with negative 4x on the left side. Negative 44 plus 16 is negative 28. I'm going to finish this problem by dividing both sides by negative 4. Now, since I'm dividing by negative 4, my symbol must flip. X is less than 7. Colored in circle on 7. Whoops, I'm wrong. Open circle on 7. X is less than, so arrow to the left. I know X is less than because the pointy end of the symbol is towards X. Let's do one more of these, a line down the middle. Again, my personal preference is to put the X's on the left side. It really doesn't matter, but that's what I'm going to start with. And I'm going to do that by subtracting 4x from both sides. Negative 2x's minus 4x's is negative 6x's. Bring the negative 10 down, symbol, negative 16. The next step is to add 10 to both sides, because I want to get that x by itself. So I'm left with negative 6x is greater than or equal to negative 6. We end this problem by dividing both sides by negative 6. Now remember, when we divide by a negative, our symbol flips. I'm going to write this up here. Symbol flips. Negative 6 divided by negative 6 is positive 1. Let's graph it. Positive 1 gets a closed circle on it because we had a symbol with a line underneath it. X is on the pointy end, which means X is less is left. And that, my friends, is all for the review. If you have any questions, please make sure to ask me or whoever is working with you. Otherwise, have a wonderful, wonderful rest of whatever day it is for you.